And this is what we have from logarithmic notations. You're told that 1 plus the log of x to base x plus 3 log 1 to base x must be equal to the log of 100 over the log of x. I know there are quite a good number of laws that a student is supposed to get introduced to before they can be able to actually get a question getting done in mathematics concerning anything to say in terms of logarithmic notations. And of course, you've been told in most cases that the log of a, for example, plus the log of b can ultimately be able to get changed to the log of a times b, so that addition can change to multiplication. And again, you can also say the log of a divided by the log of b can be able to translate into the log of a divided by b, so that division, or you can say minus, for this case, can change to division. So log a plus log b is the same as the log of a times b. Then the log of a minus the log of b is the same as log a over log b. So you divide when you have actually been given a minus sign. And of course, the log of a to base a is just 1. That means the log of a number to the base of the same number, the answer is 1. And of course, if I decide to write down this, let me say I have been given the log of a and there is maybe a b here. This can get changed into the log of a to power b, so that this one can actually end up becoming a power for that matter. It can still get dropped to mean b log a. So then with that information, I think we may not go into much of what you need to know. And of course, if you have to actually get given this, you're told maybe the log of a to base x. That is the same as saying 1 over the log of x to base a. So I can actually interchange these two when a reciprocal of that is obtained in that case. And that means you're going to actually end up having this becoming now the log of that number to be actually able to get gain of, can be able to pick a as the base now in that matter. So then let's get back to the question. I'll then come and say 1 plus the log of x to base x is just 1. Why? Because the log of a number to the base of the same number is 1. Then you shall say plus, I told you about this, you can take this 3 and let it become a power. So it can be now the log of x and this 1 to power 3. Correct? Then you shall head to this and you shall be able to say this is equal to, so the log of 100, and of course you are assuming that the base here is 10 because there's no base, so let's take this to be the base. Now that is base 10. So that means this is going to be 2 over log x. Correct. So log 100 is the same as just the log of 100 to base 10, which is just 2. How did I get 2? So 100 how many times, or 10 how many times can give you 100? So 10 power what can give you 100? 10 power 2 can give you 100. That's just the same. We can be able to actually have that getting done very easily. So then we shall have 1 plus 1, that is 2, plus log 1 to base x. This is equal to 2 over log x. Wow, nice. So we can be able to remove this log x. So we shall say times log x. Okay, then times again log x here. The log of x. Then again times log x. So that this and this will disappear. So we shall have now this and this. We shall be able to have 2 log x. Then plus. So this is going to be log x times, and of course the bases are different, so we can be able just to have log x, then into, there we go, log 1 to base x. This must be equal to 2. Great. So that if we have this, we can be able to factorize out log x. So we shall have log x into 2 plus the log then 1 to base x. This must give us 2. Very good. So I think from this end we can now be able to have 2 plus this. So I think this and this is 2, so we can take 2 on this side very easily. So we shall have log x, that is squared, plus log x into log 1 to base x. The answer must be equal to 2. So this is a log, and of course these ones are actually having, of course, the same base for that matter. So we can just decide to end up having this. We can be able to say the log into x squared, then right. So we are combining, so it will be times log 1 to base x to give us 2. We shall assume this is 10. Let's take it to be to base 10 because there's no base for that case, so that we can drop the log so that we can have x squared plus times, not plus, times log 1 to base x is equals to what? 100. Very good. Wow, so we have this, then this. So let's change the base. I'll end up having x log 1 to base x, so this x squared, that must be equal to 100. So I can be able to have x squared getting equal to this, and then log this getting equal to, so you can be able to have x squared is equals to 100, get the square root, so that we can have x being equal to plus or minus 10. Then the log of 1 to base x is equals to 100. So I can have 1 is equals to x raised to 100. So I want to get the value of x. So I just come here and say 1 is the same as what raised to 100. That is the question now. I will use logs. So I'll come here and say log 1 is equals to log x raised to 100. So if I drop this, I'm going to have log 1 then is equals to log 100 log x. So I divide by 100, divide by 100. So I'll end up having log 1 divided by 100. So log 1 divided by 100. So log 1 then divided by 100. So it gives me 0. So then 0 is equals to log x. So of course the antilog of x is just x. The antilog of log x is just x. So and then shift log of 0. The answer is 1. So x can either be 1 or x can be 10 plus or minus.